Hello, I'm Abisai, and my exercise was the number one, and I'm going to comment what I did in this exercise, because I don't want to take a long time in this video. Um, well, for the first time, I read with analyzing all the problem. Um, the problem asked me two questions. The first one, I have to calculate the maximum height in 1.2 seconds. And for the second, I have to calculate the initial angle for the player A. So in this problem, we have more data for the player B. And what I did at first, I calculate the coordinates according for the Cartesian plane, and I put the numbers as you can see in the video, and then I got all the data that I will use for this problem, that is the initial velocity j and the theta and etc etc, calculate so the final velocity. But I have a problem, I don't have the time. And what I do, simple. I choose one of the formulas for final velocity, including the time as a variable, because I have the others data, so I can help me. And after calculate this new equation, like an equation, normal equation, I'm going to make two new equations to use the substitution and calculate velocity, final velocity. Well, as you can see in the video, I use the formula for final velocity equals to initial velocity plus acceleration times time. And I'm just got a new variable. I don't have the final velocity, and also I don't have the time. But what I can do, I can find the time using. And here, to find the variable t, I use only clear the previous equation for final velocity, because I have to calculate t. I need t to find the velocity, the initial velocity. That another equation for final velocity includes the variable t. So I'm going to use this formula. As you can see for the letters in blue, this is the formula that I use, and use only clear as to find a new variable for final velocity. So now I have two equations, that's number one and number two. And what I'm going to do, simple. I'm going to calculate the final velocity using substitution the equation 1 in equation 2. And my objective in this step is to eliminate the time, the variable time. And here is only use simple algebra, and use clear the equation to find final velocity. So I think here is not a problem, just only to manage our variables, numbers, and signals to have the correct answer. So final, I got that final velocity is equals to 8.66025 meters divided by seconds. So as the final of all of these equations, I got the final velocity. But this final velocity belongs to the player B. And now I'm going to calculate the initial velocity, because the initial velocity, the problem says that initial velocity equals to 3 times the final velocity. So now I have the final velocity, and just only doing for just a multiplication, I got that initial velocity equals to 26 meters by seconds. So we are close to find the answer for letter A. Now I have the initial velocity, and having the initial velocity, we have all. At the first that I did is calculate the angle for the player A. So I use this formula that using projectile motion equation that is given in red in the video. I solve normally this equation as all the equations clear and finding the theta. So at the end, theta I got that is equal to 70 degrees. So I'm here from the editing video, and here it's not a problem for using the physics. It's just only answering and use the correct as correctly the calculator, because we can confuse and we can get a different result. So as an advantage to have the initial velocity, we can calculate y max, and as in the same and the previous exercise, the formula for this is given in red as the video. And as the same, we have all the data for clear the equation and got the y max. And after all of this, I have to do in my calculator, and I got that y max is equals to 7.10 meters. Well, at the final, I got all the variables that was missing for this problem, and let's answer this question for letter A that tell us what is the maximum height from which the ball hit. We have previously the height for the persons the player A, and the problem give us that is 25 meters, and usually we have to sum the new height that we find for y max, and at the final I got 32 meters. For letter B, well, using previously the projectile motion equation, we got the angle, so that is the initial angle for this problem. What is the initial angle at the watch is kicked? It's 27 degrees. I got these angles because I used using projectile motion equations that we have to calculate the initial velocity. Well, we don't have it the initial velocity previously, so we have to calculate the velocity, the final velocity, and the time, and dilating the time because we have two variables, and final I got the initial velocity that is the key for this problem. So having the initial velocity, we have all of this. So thank you very much for watching this video.
Today I'm going to show you how to solve the exercise 2 part 2 of the physics homework 3. First, we need to analyze the available data of the exercise. In this case, it says the kitchen radius is equals to 5 meters, and we assume that the static friction coefficient is 0.68 meters by seconds. The first problem requires to calculate the minimum speed a human can run. So we made a force diagram in which the frictions goes above, the floor goes below, and on the right is the room's center. Then we got the formula Fa equals a times b squared by r. Those formulas will be replaced by these ones, where Fa equals n, and n times m by s is the friction. So we develop the formula, and see the result. It says m times b squared by r is equals to m times g by m times s. Considering that, we can say root square of radius multiplied by gravity and divided by friction is the result we were looking for. As you can see here, where 3.5 is radius, 9.8 is gravity, and 0.68 is the friction, all equals to 7.1022 as the minimum speed. And that's the first one. The second one asks for which is the maximum speed a human can run, and if it's possible that scientifically reach that speed. The scientist Wigan says the theoretical limit a person can run in 100 meters is 9.58 meters by seconds. So that's what a person can reach. But we know Usain Bolt at Olympics reached 10.43 meters by seconds. So we could say that it's actually possible to reach the theoretical speed of 9.58 meters by seconds.
Hello, good day. This is the third question of the homework. It reads as follows. Block A has a mass of 3.70 kilograms. Block B has a mass of 2.30 kilograms, and Block C has a mass of 2 kilograms. The coefficient of kinetic friction between Block A and the inclined plane is 0.45, and theta equals 40 degrees. The pulley serves only to change the direction of the cord connecting the blocks. The cord has negligible mass. Find A, the tension in the cord connecting B and C. And the second question is, problem, the magnitude of the acceleration of the blocks. So this problem gives us this triangle right here with a pulley and 3 blocks right here. We have theta here, and well, that's it. So to make this faster and easier, I just made all of it right here. For your comprehension, I tried to make it the cleanest I could so you could understand. So this is the same as the problem right here. As you can see, it's the same, but now the instructions, all the data is right here. As you can see, the block A is 3.70 kilograms, theta is 40 degrees, B equals 2.30 kilograms, and that's it. So first of all, the problem tells us that we need to find the tension in the cord connecting B and C, which is this right here. But first, we need the acceleration because right here the formula won't allow us to. So we need the acceleration. But oh, what a surprise, we can't use the acceleration without the friction. Wow. So first of all, you need to take the friction. We need to find the friction in this problem right here. So how do you do that? Well, we have this beautiful formula right here, as you can see, and with this formula we can find the friction. So the friction is the mass of A by gravity. First, this is the first step to find the friction, the mass of A by gravity. So this is the mass of A, which is this right here, 3.70 by 9.81, which is the gravity. We all know that, right? So it's the answer is 36.297. Okay, so I just rounded up to 36.30 newtons, but you can just leave it like that, you know. And the second part is the same, but with the mass of B. B, we know that it's 2.30 kilograms, so it's 2.30 by the gravity, which is 9.81. This equals 22.56. I didn't round it up because it was lower than 5. So the third number, newtons. So now we can find the friction finally. So the friction is 0.45, which is this right here, and we have it in the problem. It's right here. As you can see, this is 0.45. So we take that 0.45 and we multiply it by 36.30, which is right here. That's it. So the answer is 16.33. Finally, we have the friction. So the next step is to find the acceleration, because we can't take the tension of B plus C if we don't have the acceleration. So the acceleration is really easy. You take this formula right here, as you can see on the screen, and you just take the data that we have and we just put it here. I changed the formula so that we can find the acceleration. So it follows 4.30, which, where did you got the 4.30? Oh my god, yeah, it's B plus C, so it's really super easy. Minus 3.70, it's the mass of A. Sine of 40, which we already have in the problem, multiplied by 9.81, which is the gravity, minus the friction, which is 16.33. It's right here, we already did that. That's the friction, 16.33. Everything, it's gonna be divided by 3.70 minus 4.30, which is the mass of A plus the mass of B plus C. So that will give us 0.31 meters per second. That's it. So finally, we get to the tension. We can finally take the tension because we have the acceleration and the friction. So the tension of B and C. First, sadly, we need the tension of A. So, the tension of A and B. So, to take the tension of A and B is 3.70, which again is it's A, the mass of A, multiplied by 0.31, which is the acceleration, plus 36.30 plus 16.33. This will give us 53.777. You can round it up if you want. Again, 53.78 newtons. And this was given to us by this beautiful formula right here. As you can see, it's not that hard. So finally, we have tension of A and B. Now we can find the tension of BC, which is gonna be easier for us because we have the tension of A and B. So this is the formula that we can use: the mass of B multiplied by the acceleration plus the tension of AB that we already have, minus the mass of B multiplied by gravity. So it goes something like this: 2.30 multiplied by 0.31 plus 53.78 minus 22.56. This, as I already told you, is the mass of B multiplied by gravity. So this is the result of all this formula right here. 31.93 newtons. And that's it. That's the tension of BC and the acceleration, as the problem told us that we need to find the acceleration and the tension of the cord connecting B and C. And that's it for me. Thank you for watching.
My name is Jesus Guillermo Avilés Granados, and today I will be explaining the exercise 4 that says a 2.0 kilogram breadbox on incline of angle theta equal to 30 degrees is connected by a cord that runs over a pole to a light spring of spring constant K equal to 120 as shown in the figure 4. The coefficient of kinetic friction between box and the inclined plane is mu K equal to 0.52. The box is released from rest when the spring is unstretched. Assume that the pulley is massless and frictionless and the system is isolated. So for this exercise we have three problems. The first is what is the speed of the box when it has moved 10 centimeters down the incline. The second, how far down the incline from its point of release does the box slide before momentarily stopping. The third and the fourth, what are the magnitude and direction up or down the incline of the box's acceleration at the instant the box momentarily stops. So, for the first exercise that says what is the speed of the box when it has moved 10 centimeters down the incline, we will be using the principle of conservation of energy that says that the sum of the initial energies is equal to the final energies, but initially we know that the box is at rest and the spring is unstretched, so it means that the kinetic energy is equal to zero. Also, the potential energy stored in the spring will be zero too. So now we rewrite the equation, and once that we have rewritten the equation, we only have four terms. We can change them by their respective expressions that will be gravitational potential is equal to mass times gravity times the initial height equal to the final kinetic energy that will be to 1/2 times the mass times the velocity squared plus the final gravitational potential that will be mass times gravity times the height or y. And for the final spring potential, it is 1/2 k times the distance that the spring is stretched to the square. But there exists one little problem, and that is that we don't have the initial height. So we know that the boat slides 10 centimeters from its initial point, and from that we can say that that is that we don't have the initial height, so we mark the initial point of the box that will be its initial height. Also, we know that it slides 10 centimeters down the incline, so it will be its final height. And if we draw a horizontal line from the final height to the initial height, we can see that it forms another triangle which has the same angle theta, and its hypotenuse will be represented by the distance that the boat slides, and that is hypotenuse equal to d. And after that we can find an expression for the initial height that will be sine of theta is equal to the height divided by the hypotenuse. But if we multiply both sides by d, we have the height is equal to d sine of theta. And to know the final height, we can simply subtract d sine of theta from the initial height. And now we can replace the y in the final gravitational potential by the initial height less d sine of theta. And now we distribute the mass times gravity with that equation. And as we can see, after the distribution is that we have equal terms in both sides of the equation, and so we can cancel terms, and we equal the equation to 0. After that, we can pass the mass times gravity times the sine of theta over to the left side. Now we multiply both sides of the equation by 2, and that will make that both of the 1/2 gets cancelled. And after that, we pass the k times x squared subtracting to the left, and then we divide both sides of the equation by m. And to isolate the equation by taking the square root from both sides, and to end the first part, or part A, we have to replace all the terms by their values, and we have the final speed of the box is equal to 0.6164 meters over seconds. And for the part B that says, how far down the incline from its point of release does the box slide before momentarily stopping? We have that the final speed is equal to 0 meters per second. And we are going to use again the same equation of the principle of conservation of energy. But as we know that the final speed is equal to 0, what are we going to do is to cancel the final kinetic energy. And after that, we have to distribute again the mass times gravity with the initial height less the sine of theta. And again, we subtract both terms in the equation, and we have the equation equal to 0. So we pass the mass times gravity times the sine of theta to the left side, and it is equal to 1/2 k times velocity squared. So now we can change the x by the d because it's the same, and after that we divide both sides of the equation by d. So now we cancel 1d, and then we can multiply both sides again by 2, and we cancel the 1/2, and one more time we divide both sides of the equation by k, and now we have this new equation that is distance is equal to 2 times mass times gravity times sine of theta divided by k. And for the last step, we just simply change the terms by their values. And we have that the distance is equal to 0.1633 meters or 16.333 centimeters. And that's all for the part B. Now let's pass to the part. And to finish this exercise, we have the part C and D that says what are the magnitude and direction up or down the incline of the box's acceleration at the instant the box momentarily stops. So for the part C, we have to create a free body diagram where it momentarily stops. And as we know, the box have a component of gravity that points straight down the ramp, and that is equal to mass times gravity times the sine of the angle, or theta. We also have that the rope is pulling up to the box, but we know that that rope is connected direct to the spring, so we have that the force on the rope is equal to K times D, that those are the constant of the springs times the distance that the spring is stretched. And as we can see is that we have two parallel forces applied to the box, and we also know that the sum of those forces is equal to the mass times acceleration. And now we mark that the upside of the incline is positive and downside of the incline is negative. So the sum of the forces will be equal to K times D minus mass times gravity times sine of theta, and that is equal to mass times acceleration. And to isolate A, we have to divide both sides by n, and we cancel the m that is next to the acceleration. And now we have that the acceleration is equal to K times D minus mass times gravity times sine of theta divided by m. And for the last step, we simply change the terms by their values, and we have that the magnitude is equal to 4.898 meters over second squared. And for the part D that asks us about the direction, we can see that the magnitude is positive. So we can say that the direction of the box's acceleration at the moment that the box momentarily stops is up the incline. And that would be everything from me in this exercise. Thank you so much.